Okay, welcome to section 3.2. We're going to be talking about logarithms. And logarithms are the inverses of exponentials. Now, we read this log base a of x. So y equals the log, the base is a to the x or of x. And that's true if and only if x equals a to the y. We'll be talking about how to rewrite from logarithmic form into exponential form. So these are equivalent forms. Y equals log base a of x, and x equals a to the y. So keep that in mind. That's really important. So we're going to evaluate these without a calculator. Your calculator does have a log button, but that log button that you see is only for log base 10. Now, we don't need the calculator right now. What we're going to be doing is log base 2 of 16 equals, and I'm going to put an x here just to make things a little bit easier for us. So now, a way we can rewrite this is take it from logarithmic form and write it in exponential form. So what we can do is start at the base, and we're going to kind of draw a little swirl. So 2 to the power of x equals 16. What we're doing is we're finding out what would the exponent have to be to get us to 16. So the exponent, 2 to the 4th equals 16. So all of that, log base 2 of 16 equals 4. That's the value that we found. We evaluated that log. Let's try it again. So remember, let's just put an x here to make it easier. And then we're going to rewrite it into exponential form. So 3 to the power of x equals 9. And now 3 squared equals 9. That was our missing exponent. So log base 3 of 9 equals 2. So when we evaluate that, we get a 2. Once again, start and write it in exponential form. Start with the base. 16 to the x equals 4. Now, we're going from a bigger number to a smaller whole number. So what we want to do is we want to take the root. And the square root of 16 is 4. So it's 16, and the square root is the same as raised to the 1/2 power. So the log base 16 of 4 equals 1/2. 10 to the x equals 1 over 1,000. A little bit more room, so we have 10 to the power of x equals 1 over 1,000. Now, to go from a whole number to a fraction, or vice versa, we have to think about reciprocal, a negative exponent. So we're going 10 to a negative number. Now, to go from 10 to 1,000, it's a 3. So 10 to the negative third is 1 over 1,000. So log base 10 of 1 over 1,000 equals negative 3. That's our value. Put an x here. 4 to the x equals 1. Now, the only way to go from a number to 1 is if our exponent is 0, because 4 to the 0 equals 1. So the log base 4 of 1 equals 0. That's our value when we evaluate. Log base 3 of 3, so it's 3 to the x equals 3. The only way we can get the same number is if our exponent is 1. So the log base 3 of 3 equals 1. And there's our value from evaluating. All right, let's go to the next part. Now, like I said, when you see that base 10, we write that as log of x. That's what's called the common log. Log base 10 is the common log. Think we have 10 fingers, 10 toes. We count with a base 10. That's why we call it the common log, because we're used to working with our tens. So now, use your calculator. You can actually just hit the log of 10, and you're going to get 1. for number 7. Log base 10 of 100 is 2. 2 times the log of 3.5, 1.0881. We rounded that. And now this is the log of negative 2. When you type that in, you're going to get an error. There's no solution here. Now, the reason that is, if I take this and write it in exponential form, 10 to the power of x equals negative 2. There's no exponent that will ever make a number that's positive into a negative. We can change a positive number to a negative number using exponents. That's why there's no solution. We cannot take the log of a negative number. It's not possible. Next page. The properties of log. So here's just some basic things. Log base a of 1 equals 0 because a to the 0 equals 1. And you can kind of read through it. The important things to remember is right here. The log base a of a to the x is x, and a to the log base a of x. Those are the inverse properties. We'll be talking about that more. And then that 1-to-1 property. See how they're both log base a of x and log base a of y? If they both have the same log base, if the log bases are equal, then you just set the numbers equal. Then x equals y. So we're going to do some simplifying here. Log base 4 of 1 equals. So now, whenever we're taking the log base anything of 1, and you can even see, it's 4 to the x equals 1. X has to equal 0 because 4 to the 0 equals 1. So the log base 4 of 1 equals 0. Whenever we're taking the log base of 1, our output's always going to be 0. That's just from that first property. Log base square root of 7 of square root of 7. Because of this property right here, the second one, those are going to undo each other. We're just going to be left with 1. They're going to cancel each other out. And you can also think about it in this way. If you put it like equals x, it's the square root of 7 to the x equals the square root of 7. The exponent has to be a 1. Using that inverse property, 6 raised to the log base 6. Since this base and the log base are the same, they undo each other. We're left with just the 20. Now, looks like we're pretty close with this. But 25 we can rewrite. So log base 5. Now, 25 is the same as 5 squared. And when you see it written that way, you see the log base 5 of 5, they undo each other. We're left with just a 2. That's using that inverse property after we rewrote. Let's do some examples using the inverse properties and change a base and all that. So now if you see log base 3 of x, log base 3 of 12, they both have the same log base. So by the 1-to-1 property, x equals 12. And we'll do a quick check. Log base 3 of 12 equals the log base 3 of 12. And you want to check these. You can see it's the same on the left and on the right. We're good. Number 16. There's no base shown. When the base isn't shown, it's log base 10. So for 16, the bases are the same. They're both base 10. So we can set 2x plus 1 equal to x. Subtract 2x from both sides. 1 equals negative x, so x equals negative 1. Now, when we check this, it's the log 2 times negative 1 plus 1 equals the log of negative 1. So we get the log, it's negative 1 plus 1 of negative 1 equals the log of negative 1. Even though that's the same on the left as it is on the right, we have something that doesn't exist equaling something that doesn't exist. It doesn't work. You can't take the log of a negative number. It doesn't exist. So our only solution was bad. So for our answer there actually is no solution. There is no value for x. It would give us a true statement. Even though the left was equal to the right, they don't exist, so it doesn't work that way. Another one, log base 3 and log base 3. So once again, one-to-one property, x squared plus 4 equals 29. Subtract 4. X squared equals 25. Take the square root. X equals 5 and negative 5. Don't forget to check. So the log base 3 of 5 squared plus 4, log base 3 of 29. Log base 3. Now 5 squared is 25, plus 4 is 29. Left-hand side equals the right-hand side, and they're both valid. There we go. Let's check the negative 5. Log base 3 of negative 5 squared plus 4 equals the log base 3 of 29. Now, negative 5 squared is positive 25, and then plus 4, it's going to be log base 3 of 29 equals log base 3 of 29. Because of the way that worked out, they're both valid solutions. We don't just always throw out the negative. In this case, we keep both. Number 18, they're both base 10, so we can use the one-to-one property. 4 minus 3x equals x plus 2. Subtract x from both sides, and then subtract 4 from both sides. Negative 4x equals negative 2. Divide both sides by negative 4. X equals 1/2. All right, let's check again. Log 4 minus 3 times 1/2 equals the log of 1/2 plus 2. So it's the log of 4 over 1, which is the same as 8 over 2, minus 3 halves. Log, and 1/2 plus 2 is the same as 5 halves. So we get the log of 5 halves equals the log of 5 halves. They both equal each other and they're both valid. The thing we're really looking for is making sure we're not taking the log of a negative number. That we're not taking the log of a negative number. That's our big thing we're trying to avoid. Next, let's talk about the natural log functions. So natural log is log base e. So since we use it often, it has a name. Log base e is also known as the natural log. And that's right there. There's the properties. The first two are very similar. And even the last two, those inverse properties and one-to-one properties. E, and there's actually something missing there. That should be e to the natural log of x. And there also should be the natural log of e to the x equals x. So make sure you add that there. Somehow that got missed. The natural log times of e to the x equals x. Those are the inverse properties. Let's use those. So the natural log of 1 over e. So what that is that's the natural log. And 1 over e is the same as e to the negative first. What they're going to do is the natural log and e undo each other, so we end up with a negative 1. E to the natural log of 5, they're inverses. They undo each other. We're left with 5. The natural log of 1 over 3. The natural log of 1. What that's saying is it's saying e to the x equals 1. So for the natural log of 1, that's e to the x equals 1. So now x has to be 0. So we end up with 0 over 3, which is 0. You can also find the natural log of 1 on your calculator. 2 times the natural log of e. Now the natural log of e is 1. They undo each other. So it's just 2 times 1, which is 2. And then finally, we're going to use our calculators to find the following. The natural log of 2, and there's a natural log button. It's right below the log button. And the natural log of 2 is about 0.6931. The natural log of 0.3 is negative 1.2040. The natural log of negative 1, you'll find out it does not exist. And the reason it doesn't exist is, remember, the natural log is log base e of negative 1. So what we'd have here, if we wrote it this way, log base e of negative 1 equals x, it's e to the x equals negative 1. There's no exponent that makes a number equal a negative. There's no exponent that changes a positive to a negative number. That's why it doesn't exist. And then the natural log of 1 plus the square root of 2. Make sure you use parentheses, and you're going to get about 0.8814. Okay, so log is the inverse of an exponential. That's the thing to keep in mind. Log base 10 is also known as the common log, which is just log. And the natural log is log base e. I will see you in the next part, and we'll talk about graphing these. Thank you.